अच्छा चले दिस वन ये पुराना पेपर ठीक है दिस इज समर 2014 ठीक है तो स्टार्टिंग विद ये थोड़े से पुराने क्वेश्चंस हैं दे वर स्लाइटली मोर डिफिकल्ट ठीक है सो स्टार्टिंग विद दिस क्वेश्चन तो so the question is कि पता नहीं there's something called aldol and a product of which is a compound a product of which is compound J shows the following property so this is J जो है ना that's this thing then it's neutral ठीक है neutral का मतलब है it's not a carboxylic acid अच्छा benzene वाला कोई चक्कर नहीं है क्योंकि there is no it doesn't even have 6 carbon atoms so we don't have to worry about benzene or any of the derived compounds फिर ये कि it reacts with sodium metal who reacts with sodium metal if it's not a carboxylic acid so it must be an alcohol it also reacts with Felling's reagent तो फेलिंग के साथ कौन रिएक्ट करता है फेलिंग के साथ इट्स अच्छा फेलिंग के साथ इट्स एल्डिहाइड ठीक है एल्डिहाइड्स they react with Felling it does not react with aqueous bromine so this indicates no double bonds अच्छा we did this part ठीक है so we know it's not a carboxylic acid it's definitely an alcohol and it's definitely an aldehyde the result of the bromine test shows the functional group is absent so we did this okay there's no C double bond C okay we did that in the boxes draw 3 possible straight chain okay remember straight chain structures for J that fit the above results and that are structural isomers of each other so C4H8O2 alcohol carboxylic acid alcohol aldehyde okay that's about it so straight chain so in all 4 cases remember uska formula kya tha it was C4H8O2 so I basically want an aldehyde and I want an alcohol okay so these are my 3 straight chains each one of them has to be an aldehyde so you can't change the position of the aldehyde group otherwise it's not going to be an aldehyde okay so it's going to be at the end it was an alcohol as well so you can kind of move around the alcohol so the alcohol could be on the last carbon atom the alcohol could be on the second carbon atom या फिर the alcohol could be on the third carbon atom from the right बाकी H's draw कर लो ठीक है these are अच्छा these are your H's ठीक है वो खुद ही लिख लेना अच्छा now the next part is compound J reacts with alkaline aqueous iodine to give a pale yellow precipitate so who reacts with iodoform test क्या होता था iodoform test was you either need a methyl with a carbonyl group or you need methyl with CHOH. In both cases, the methyl will break off and it will form a yellow precipitate of CHI3. और वो जो दूसरा part है ना, that would turn into a carboxylic acid. So which functional group does this reaction show that J contains? Definitely you don't have a methyl. तीनों के अंदर you don't have methyl. कौन सा वाला होगा इन तीनों में से option? किसका iodoform test positive होगा? वो ये वाला होगा. It's going to be CH3. CHOH. ठीक है, L. So CH3 CHOH. That's going to give a. So यहाँ पे he's asking what does it show? So it's probably going to show you this thing that it's got CH3 CHOH. That's a group that's going to be present. So which of these structures that's going to be L? Then he says compound J exists as stereoisomers. Then the type of stereoisomerism shown by J. So कौन सा stereoisomerism है? That's it's obviously chiral. ठीक है, around this carbon atom it's chiral. तो optical isomers. ठीक है, so it shows that it can make optical isomers और उसको draw करने को कहा है, so you can quickly draw that. कि क्या है, इधर ही draw कर लेता हूँ. So it's going to have अच्छा एक साइड पे CH3 है, then you have CHOH, and then on one side you got CH2 and you got an aldehyde. And the other one would be the exact mirrored version of this. So OH गलत कर दिया, the CH3 उधर नहीं होना. CH3 would be on the left side or most side पे CH2 CHO. Anyways, those are your two mirrored versions. बस ठीक है, वो part खत्म हो गया. Now the next part is about amino acids. Or amino acids में he's given you two amino acids. He's given you valine and serine. So dipeptide draw करना है valine or serine. So what is an amino acid? It's got a carboxylic acid group, and it's got एक side पे it's going to have H. One side it's going to have NH2. And on one side it's going to have an R group. So ये पहले वाले में, what is the R group? This is the carbon. One side it's got a carboxylic acid group, one side it's got an amine, and on one side it's got an R group. So the R group over here is a carbon with two CH3s. ठीक है, वो ये वाला है. So the other one is going to have exactly the same structure. It's going to have carboxylic acid, and it's going to have NH2. एक साइड पे H होगा. इसका R group क्या होगा? The R group is going to be that it's got a carboxylic acid, it's got an amine, फिर एक साइड पे there's this R group. So CH2OH. So CH2OH, that's the R group, ठीक है. So how would a dipeptide get formed? The OH and H are going to undergo a condensation reaction, and they will link up. ये दोनों आपस में link up हो गए. That's your dipeptide. What type of reaction has taken place? Condensation. Identify the other molecule that's produced. That's water. Water is always produced. अच्छा, DNA, RNA, that's not in your course. ये सारा भी नहीं है. अच्छा, this one is about electrophoresis. The modern methods in chemical analysis often rely on interpretation of data gathered from instrumental techniques. The electrophoresis and paper chromatography can both be used to separate amino acids. from a mixture of obtained from polypeptides. So in each, give one property of the amino acid that causes their separation. So electrophoresis में it's the charge on the amino acid. अगर वो charge नहीं होगा, it won't move. ठीक है? One side is negative, the other side is positive. So if the amino acid is positively charged, it will start moving towards the negative side. Vice versa, if the amino acid is negatively charged, it will start moving towards the positive side. और पेपर क्रोमेटोग्राफी में सेपरेशन क्यों होती है? वो it's the difference in solubility of amino acid between the mobile phase and stationary phase. तो अगर आपका amino acid जो है that's more soluble in the solvent, then it will move a lot of distance because it will travel along with the mobile solvent. अच्छा, अगला पार्ट है कि उसको फाइंड कैसे करते हैं amino acids. How are positions of the amino acids made visible? ठीक है, you add locating agents. क्योंकि amino acids are essentially colorless, so you would have to spray it with a locating agent. Which measurements need to be made in order to identify individual amino acid in paper chromatography? So उसके अंदर measurement क्या होती है? It's retention factor, which is RF value. So what is that? Distance traveled by the amino acid. Or divided by the distance that is traveled by the solvent. खैर ये वाला पार्ट आसान था, ये वाला आ गया. इलेक्ट्रोफोरेसिस. तो वो कह रहे कि ये कोई मुझे बता दे कि how would you identify the individual amino acids? Which one is T? In Salome, which one is going to be T?
Is it lysine?
Because lysine overall is positively charged because it's got a +1, it's got another +1, it's got a -1. So it's got 2 +1 charges and it's got 1 -1 charge. So the overall charge on this thing will be +1. So T is attracted to the negative side. तो फिर वो lysine ही होगा. ठीक है, that's अच्छा, this one is lysine. बाकी बता दो कि वो कौन सा जो मूवी दिखा रहा, that's
Glycine.
ठीक है, that's glycine क्योंकि overall it's neutral. ठीक है, this one is a zwitterine at the moment because it's got regions of negative and positive charges, but it overall has no charge, so that's glycine. S is glycine. और R जो होगा ना फिर वही होगा जो क्या है, glutamic acid. ठीक है, that's your R. अच्छा, paper chromatography. अच्छा, they've done a two-way paper chromatography. हमने थोड़ा सा we did this. Your question most likely it's not going to be asked anymore, but it's a simple question. Maybe it might be asked. Okay? They've not expressly stated that it's no longer in your course, but so we'll probably do this one. To answer these questions, you need to indicate clearly on the diagram above as directed. Put a U next to the amino acid that traveled furthest. The paper chromatography or two-way chromatography, what you would do is you would first make the amino acid or the mixture of amino acids travel a particular direction by doing chromatography. The amino acids, when this amino acid, it will start traveling upwards. It will separate into different amino acids. ठीक है, तो ये 1 है, this is 2, this is 3. You got 4 spots, right? then you do exactly the same chromatography but with using a different solvent but in the other direction. Paper को उल्टा करके ना फिर आप दूसरी direction में उसकी paper chromatography करते हैं using solvent number 2. So these amino acids, they travel along the other solvent in the other direction. Once you ये वाला तो travel ही नहीं कर रहा था, ठीक है? This one separated into further amino acids, एक पीछे रह गया था, वो भी separate हो गया. So that's your two-way paper chromatography, that you do it in one direction and then you do it in the उसी paper को ना उल्टा करके दोबारा कर लेते हो with another solvent and you do it in the other direction. Because when you use two solvents, separation is better क्योंकि it's जैसा ये दोनों है ना, if you hadn't used solvent number 2, then these two would have been at the same spot in solvent number 1. But solvent 1 ने ना इनको separate ही नहीं किया था. But is this clear that these two spots were not separated or resolved using solvent number 1? आपका solvent number 2 था जिसने जाके उनको separate किया. तो ये idea clear है ना, ये two-way paper chromatography. Is that clear?
Yes.
मैं फिर से बता दूं, chromatography जो है ना, specifically paper chromatography, we did this in O-levels, it's very simple, ठीक है? तभी explicitly ना syllabus के अंदर ना it's not written that way, लेकिन आसान है, तो let's just वैसे prepare कर लो. अच्छा, put a U next to the amino acid that traveled furthest in solvent number 2. Furthest in solvent number 2 इस direction में, तो ये है ना, it's this one, right? That is the one that traveled the furthest in solvent number 2. Put a ring around the two amino acids that were not separated in solvent number 1. वो ये दो हैं, these two were separated using solvent number 2 ना होता तो ये दोनों तो यहाँ पे होते, ठीक है? Put a W next to the amino acid that was very soluble in both solvents. ये कौन सा वाला है? Very soluble in both solvents.
सर टॉप वाला जो ऊपर है,
ये वाला.
यस सर.
ठीक है, क्योंकि इससे पहले ये सॉल्वेंट नंबर 1 में ट्रैवल कर रहा था, फिर जब यहाँ तक पहुंचा, फिर उसके बाद आपने दूसरा सॉल्वेंट यूज किया तो वो फिर इधर ट्रैवल करना शुरू हो गया उसके साथ, तो इससे दोनों में ज्यादा डिस्टेंस ट्रैवल किया, ठीक है? सो तो ये वाला है. तो ठीक है, पेपर क्रोमेटोग्राफी ना इसलिए थोड़ा बहुत तैयार कर लो क्योंकि O-levels में you did this, at least you did one way, two way is not that different. अच्छा, name an example of a synthetic addition polymer and a synthetic condensation polymer. So addition polymer, alkene से कौन सा polymer बनता था? PVC बनता था. You had just a pipes वगैरह, ठीक है? That's one. PTFE, that was Teflon वगैरह. You also had polyethylene, your plastic bags, etc. ठीक है? Polyethylene bags. Condensation polymers में you had a lot of them. You had nylon, polyamide, ठीक है? That was as a nylon. You had or synthetic, ठीक है? Not natural. क्योंकि natural में ना proteins भी आ जाते हैं. अच्छा, और कौन सा condensation? Terylene, that's polyester. Fabric बनता है. बस एक आध example जो O-levels में था ना, वो you have to remember that. Now, addition polymers are long-term pollutants in the environment, but condensation polymers are often biodegradable. What type of reactions occur when condensation polymers biodegrade? Let's remember, condensation polymers जो होते हैं, they're always very biodegradable, ठीक है? ठीक है, hydrolysis. अच्छा, they're always very biodegradable क्योंकि polyamides have amide linkages. And polyesters have ester linkages, which are highly polar. So, usme carbon is very positive, and so it's very polar. So they attract water and they hydrolyze very easily. कि ये वापस टूटेगा, the ester link will break and it will again form the carboxylic acid, and that side will again form the alcohol. जैसा वो प्रोटीन्स भी बायोडिग्रेड कर जाते हैं ना, दैट्स कहाँ गया, हमने बनाया था अभी, जो हमने बनाया था वो किधर गया, वो ये था, वाटर निकला था इधर, वापस टूट जाएगा, वाटर वापस ऐड हो जाएगा, ठीक है, सो OH इधर आ जाएगा, H will get added over here, so the amine and the carboxylic acid would reform. So hydrolysis happens very, very easily, but not in addition polymers. In addition polymers में ना, you have a carbon chain. अच्छा, identify two functional groups that can undergo, यही दो functional group के नाम कह रहे हैं वो, कहते हैं कौन, तो amides and esters, they can obviously undergo this. अच्छा, they can undergo this reaction. अच्छा, अब ये है कि one second. Petroleum is a non-renewable. Draw the displayed formula of the repeat unit of a polymer using both monomers. तो इन दोनों से बनाना है, तो ये CH है बीच में, ठीक है, the middle part CH. अच्छा, we've got an OH and we've got a carboxylic acid as well. और वो CH के साथ है, there's a CH3 as well. इधर क्या, I've got a CH2. I've got a carboxylic acid. And I've got an OH. तो क्या होगा, it's going to form a ester link. इधर से OH आएगा, इधर से H चला जाएगा, and they will join up in the middle. So they're going to join up and they'll form an ester link, ठीक है, उसको थोड़ा करीब करीब बना देना. अच्छा, लेकिन it's going to continue, it's going to be a polymer, so वो OH साइड से भी जाएगा, इधर से H जाएगा, so the linkage will continue at the ends. तो आपने ना, make sure you leave a continuation bond over here, कि भी काम आगे चल रहा है, और put an N, ठीक है, that's your polyester. अच्छा, monomers, ये clear है ना ये चीज, monomers obtained from plant sources do not usually form addition polymers. Monomers obtained from plant sources do not form addition polymers. तो क्या addition polymers are formed by alkenes? तो बस एक ही रीजन होगी, monomers are saturated. क्योंकि addition polymers जो होते हैं वो बनते हैं जब alkenes होते हैं, ठीक है. If you don't have an alkene, they are not going to form addition polymers. अच्छा, फिर diagram shows two sections of two polymers, Y and Z. What would be the main force between the chains in each polymer? तो इधर polymer chains के बीच में क्या attractive force होगी? पहले वाले में, the first one is van der Waals forces, ठीक है, it's non-polar, ठीक है. It's just a carbon chain. So the first one is non-polar. So non-polar के अंदर you only have van der Waals. अच्छा, इधर क्या होगा, इधर हाइड्रोजन बॉन्डिंग होगी. NH जब भी होता है ना इकट्ठा, तो that's the strongest attractive force would be hydrogen bonds. Hydrophilic कहते हैं water attracting को. Which of these पहले थोड़ा बायो होता था तो हाइड्रोफिलिक यूज होता था. अच्छा, हाइड्रोफिलिक is water attracting, so obviously this one is the one that's going to attract water molecules, ठीक है. चलिए, clear question.
Does Z have any dipole forces as well?
Obviously it's going to have dipoles as well.
if I wrote that, it would be fine.
But the strongest होगी वो उससे main force ना. So I think he's looking for
Okay.
the strongest, right?
Right.
This is a पिछला question कर लेते हैं. This one is about benzene. So bromination. What type of reaction? Alkenes में कौन सा होता है? That's electrophilic. Addition. और benzene में क्या होता है? That's electrophilic. Substitution. So okay, bromine में ना, how is the electrophile created? So Br2 reacts with AlBr3, and what happens is that AlBr4 minus 1 gets produced, and a Br plus 1 electrophile gets created. I said दोनों cases where he's asking for the intermediate. तो benzene में क्या होता है? When the Br plus 1 gets created, so the Br plus 1 grabs electrons from the benzene ring, which becomes partial. वो double bond में भी यही होता है कि when a Br plus 1 gets added to it, a carbocation gets produced. जिसमें फिर Br minus 1 आके attach हो जाता है. अच्छा, suggest why the product of the reaction between bromine and benzene is still unsaturated. But why is it still unsaturated? So, well, क्या लिखोगे? इसका pi bond gets reformed. इसका exact देख लेते हैं एक second. Okay, and H leaves electrons and the pi bond in the benzene, it gets reformed. So just 1 second. So ये वाला part तो कर लिया. हाँ, मतलब वो ये is unchanged after the reaction, so we can say pi bond gets is reformed at the end of the reaction. ठीक है, the H loses electrons and the pi bond gets reformed. अच्छा, अगला part के you've got a methyl and अच्छा, इधर मुझे बताओ कि there's substitution that's happening. कौन से दो reactions हो रहे हैं यहाँ पे? तो मैं खोल भी लेता हूँ. I said the two reactions that are happening. नहीं, alkylation नहीं है. कहाँ पे? There's no alkylation. Methyl किस तरह carboxylic acid में change होता है? What happens when a methyl changes into a carboxylic acid? अगर इसको ये oxidation है, ठीक है? So that part is oxidation. वो KMNO4 either show भी हुआ होगा कि कहाँ पे methyl changing into carboxylic acid. Just a second. ये वाला KMNO4 के साथ उसको heat करो, it will turn into a carboxylic acid. And there's chlorination that's happening. अब मुझे बताओ कि in this case, will you chlorinate it first, electrophilic substitution? what is the methyl group? Is it 2,4,6 directing or 3,5 directing? So methyl group hai. Remember methyl group jo hota hai, that's 2,4,6 directing. Electron donating group hota hai. So the electron density increases at positions 2, 4, and 6. So if you were to chlorinate this, the chlorine would get attached to either positions 2 or 4. So you're definitely not chlorinating it first. You're first oxidizing it. और उसके बाद फिर उसको chlorinate करो. The carboxylic acid group is an electron withdrawing group. So the chlorine is going to get attached to positions number 3 and 5. So for reaction 1, it's KMnO4 acidified in reflux. Achha, for the other one, that's we catalyst wala Cl2 plus AlCl3. And that's your catalyst. So considering the following synthesis, structure G find out karna hai. What exactly is structure G? So carboxylic acid is turning into an amide. Now, one way to actually turn a carboxylic acid, here my carboxylic acid hai. So remember, amides, this is my carboxylic acid, and this is my amide. So carboxylic acids can also directly turn into an amide, but that's kind of difficult. What usually happens is that carboxylic acids are first turned into, asme ammonia ke saath wo directly react nahi kar sakte because they would have an acid-based reaction. Because this is an acid and ammonia is a base. So instead what happens is you turn it into an acyl chloride first. The pehla jo reaction hoga na, that's the carboxylic acid turning ACl laga hua hai. And the carboxylic acid turns into an acyl chloride. That's PCl3 plus heat. और फिर acyl chlorides are turned into amides. तो उसके लिए तो बस अमोनिया ही चाहिए होता है, उसके लिए कुछ खास चीज उसके लिए कुछ चाहिए तो नहीं होता. HCl प्रोड्यूस होगा तो शायद एनीवे चाहिए होगा, इसका देख लेते हैं पार्ट ई के अंदर. नहीं कौन सा ऐसे नहीं, इसकी वो बात कर रहा, रिएक्शन नंबर 4, सॉरी. He was asking for this and this one. अमोनिया के लिए कुछ नहीं चाहिए. Reaction number 4 is amide turning into amine. ठीक है, that's also this part. In amide over here, LiLH4 डालो तो it will turn into an amine. वो जो serial bond हो है ना, that will turn into CH2. It will get reduced. तो ये वाला reaction अगला LiLH4. So this part. ये याद रखना कि acyl chloride वाले most reactions you don't really need to do much because most reactions of acyl chlorides are very, very vigorous. तो ये भी खत्म हो गया, ठीक है. अच्छा फिर से एक और बीच वाला पहले कर ले. अच्छा उसी का. अच्छा वो क्या है, which of these compounds can exist as optical isomers? So I guess D is an optical isomer. Who else? B is an optical isomer. ठीक है, this is chiral. So you've got two carbons which are chiral. So B and D. No chiral over here. No chiral on this one as well. So on hydrolysis, which of these compounds produces a secondary alcohol? So hydrolysis hoga to ester link will break. All these ester links are going to break. Ye wala jo hoga na, it's going to form a secondary alcohol because it's going to look, the carbon chain is तो इसका जो alcohol होगा ना, it's going to look like this. C किसका chiral है? ये chiral नहीं है, ये वाला part, it's two carbon chains. Same, CH3, CH3. Is that clear कि C chiral नहीं है? अच्छा, तो ये secondary alcohol बना रहा है, I guess. The rest are all making primary alcohols. The hydrolysis of all these compounds, ethanoic acid is one of the products. State the reagents and conditions needed for hydrolysis. So, वो ester को तोड़ना है, तो that's just dilute acid, sulfuric acid, let's say, plus heat or reflux. So all hydrolysis will happen this way. अच्छा, K का वो strength of acids पूछ ही रहे कि भाई ये ethanol, why is ethanol such a bad acid? Well, the question है. Just 1 second. अच्छा. Question is, why is ethanol such a bad acid compared to carboxylic acid? So the acids का comparison है. So when you are right कि ethanol के लिए dissociate होना मुश्किल है, ठीक है? Why is it so difficult? Because it's got a carbon chain. मतलब basically दो लाइनें लिखो. It's got an electron donating alkyl chain. The negative charge density on this ion increases, making it very unstable. Or you can say that this attraction or the strength of the OH bond increases. So less dissociation. तो बस वो electron withdrawing effect, sorry, electron donating effect, negative charge density on the ion increases and making it very unstable. अच्छा, why is chloroethanoic acid a stronger acid? Why is it a stronger acid? क्योंकि जब compared to ethanoic acid, क्योंकि जब carboxylic acid ionize करता है ना, the chlorine has an electron withdrawing effect. So the negative charge density over here decreases, making it very stable. Or you can say that the OH bond weakens. मतलब negative charge होता है वो छोटा हो जाता है, small हो जाता है. So it's no longer going to attract the H+1. तो इसलिए अच्छा, फिर ये कि pH of ethanoic acid. How do you calculate the pH of a weak acid? This is what a weak acid dissociating looks like. तो क्या होगा इसमें कि K would be product concentration divided by, so it's going to be H+1 squared divided by the acid concentration. मतलब ये दोनों की concentration exactly same as divided by the acid concentration. So you have the value of Ka, I guess. उसे दिया हुआ है, it's 1.75 times 10 power minus 5. That's given. तो 1.75 H+1 squared is not given. Acid concentration is also given. That's 0.1. इधर मुझे बताओ इसकी वैल्यू के डायरेक्ट pH ही बता दो कि क्या आ रहा है. इसे कैलकुलेट करके बताइए क्या आ रहा है इसका। ठीक है 2.88। अच्छा अगला पार्ट, that's about a buffer solution. So he says that NaOH and ethanoic acid, तो ये reaction चल रहा है, it's ethanoic acid reacting with NaOH. Now base and acid react, they would form a salt. Ethanoic acid, sorry. So it would form salt plus water. So anyway, so इसके moles कितने होंगे? That's NaOH के, that's 2 times 10 power minus 3 moles. And what are the moles of ethanoic acid? That's 1 times. अच्छा NaOH excess में. अच्छा so ethanoic, it's not a buffer. Ethanoic, so ethanoic acid is 1 times 10 power minus 3. So that means that the ethanoic acid is going to get completely used up. और ये पीछे कितना रह जाएगा? 1 times 10 power minus 3 is left. और आगे salt कितना प्रोड्यूस हुआ है? That's 1 times 10 power minus 3. क्योंकि it's 1:1, so 1 times 10 power minus 3 reacts with 1 times 10 power minus 3. So 2 में से ना 1 is left, and it's going to produce 1 times 10 power minus 3. So OH in concentration. So NaOH कितना पड़ा हुआ है? कितना moles? Concentration क्या होती है? Moles. So how many moles of NaOH do you have? That's 1 times 10 power minus 3 moles. और solution का volume क्या है? Volume of the solution is 20 cm cube of this, 10 cm cube of this, that is 30 cm cube. तो यानी ये सब कुछ जो है ना 0.03 dm cube में पड़ा हुआ है. 30 cm cube I think उतना ही बनता है. So what is the concentration now? Okay, I guess we divide by. अच्छा 0.0. मोल पर डीएम क्यूब. फिर कह रहे कि पीएच निकालो. और ये एक्सप्रेशन KW क्या होता है? That's 1 times 10 power minus 14. H plus 1, you don't know what H plus 1 is. OH minus 1 का पता है, that's 0.0333. So take the 0.0333 to the other side and find the pH now. What do you get for pH? That's 12.5. And he's asking you to sketch a titration curve. So initially you were adding NaOH from the top and you're adding it to ethanoic acid. जो कि कितना था? That was 0.1 mole per dm cube ethanoic acid. जिसका pH हम निकाल चुके हैं. उसका pH हमने कितना निकाला था? 2.88. 0.1 mole per dm cube का. So your starting pH is 2.88. That's your starting pH. अच्छा तो एंड कहां पे जाके हुआ है? दैट्स अ स्टार्टिंग पीएच. फिर एनीवे जब एक्सेस में डाला था तो पीएच कितना हो गया था? दैट वाज 12.5. दैट वाज योर एंड. न्यूट्रलाइजेशन किस पॉइंट पे होगी? अगर 20 सीम क्यूब और 10 सीम क्यूब डालोगे तो 10 के ऊपर न्यूट्रलाइज हो जाएगा. सो इट्स ओनली, सो दैट मींस your starting pH was around 2.88. When NaOH went in excess, it was what, 12.5. तो यहाँ पे होगा. And neutralization point would have, equivalence point would have been at 7. ठीक है, 10 सीम क्यूब डालने के ऊपर 20 was in excess. So you're going to make a titration curve. Just make sure that most of the curve will have a pH change that will happen around the equivalence point. शुरू में और बाद में ना pH change इतना ज़्यादा नहीं होना चाहिए. What is a suitable indicator for this? I guess 9 to 10 would work. 9 to 10 ये. तो अगर यहाँ पे ना color change हो जाए ना, so we would be able to stop at 10. ठीक है, is this question clear, this one? चलो ठीक है, चलिए शाम को कंटिन्यू करेंगे. ठीक है, ओके देन, टेक केयर.